This video is over logic, conditional statements, converse, and inverse statements. A statement in general is pretty much just like a sentence. So the statement that we'll use for our examples are an angle that's straight has 180 degrees. So once you have a statement, you can turn it into what's called a conditional statement. A conditional statement is an if-then statement, which means the beginning of the sentence starts with if, and in the middle of the sentence you have a then. A conditional statement can be written as P, then Q. If P, then Q. P stands for the hypothesis, Q stands for the conclusion. So in this example right here, I transformed this statement. An angle that is straight has 180 degrees. Into a conditional statement. Notice the meaning of this statement doesn't change. It says if an angle is a straight angle. So an angle being a straight angle is your hypothesis. That's your P. Then its measure is 180 degrees. So its measure being 180 degrees is your conclusion. So that's your Q. So the hypothesis is your P. The conclusion is your Q. So if, then statement. So going from what we just did on the other page, we're going to use this conditional statement. If an angle is a straight angle, so that's going to be our P statement, then its measure is 180 degrees. So that would be our Q. So this is the hypothesis right here, and this would be our conclusion. So notice the symbols. If Q, remember, is our conclusion, and P is our hypothesis. So the converse right here is where we switch the hypothesis and the conclusion. So the converse is written like this. It says if an angle has a measurement of 180 degrees, then it's a straight angle. So notice up here from my conclusion, I highlighted, or from my conditional, I highlighted my original hypothesis in yellow. And then notice I went down to my converse, and my hypothesis is now after the word then. Conclusion highlighted purple right here, and at the beginning of the converse, whereas it was at the end of our conditional. So now it's found after the word if. So the converse is just switching your hypothesis and conclusion, switching which comes first in your sentence. The inverse negates the hypothesis and the conclusion. So this symbol P means to negate. So in an inverse, you still have an if and a then, but notice the words not. Let's say I had the sentence, it is snowing outside. If I wanted to negate that, I would say, it's not snowing outside. So using words like not and won't and can't and isn't, those are negating words. So here's our original conditional statement that we started working with. If an angle is a straight angle, then its measure is 180 degrees. And then the inverse of this, it says if an angle is not a straight angle. So I used the same part of the hypothesis, but I just inserted this word not. Then its measure is not 180 degrees. So again, we just inserted this word not here. So that's the inverse. The other thing with a condition, converse, and inverse is figuring out the truth value. Each sentence that you write can either be a true sentence or a false sentence. So in order for a sentence to be true, every time the hypothesis is true, the conclusion must be true as well. If your sentence is false, you'll have to provide what's called a counterexample, which means you'll have to give a reason or give an example on when the sentence is false. So here's how your questions will work in general. This is a statement. The conditional for that statement, we would also have to write. So starting off, our statement is, a rectangle has opposite sides congruent. So our conditional for that would be, if it is a rectangle, then it has opposite sides congruent. So go ahead and write that. Okay, so our conditional for this statement would be, if it is a rectangle, then it has opposite sides congruent. So after you write this sentence, you need to determine whether it is true or false. So if you have a rectangle, so we have to assume that this is the hypothesis, is true, then you have a rectangle. So is the conclusion true if you have a rectangle? Okay, so for this, if it is a rectangle, then it has opposite sides congruent. So if I have a rectangle, are the opposite sides congruent? And the answer to that would be yes. So this would be true. Now, with the converse, it switches your hypothesis and your conclusion. So my converse is going to look like, so here's your converse. We would say, if it has opposite sides congruent, then it is a rectangle. So go ahead and write that. If it has opposite sides congruent, then it is a rectangle. So again, we need to refer to our hypothesis. Our hypothesis is whether whatever shape you have, opposite sides are congruent. So then you have to ask yourself, every time you have opposite sides congruent, is it a rectangle? And the answer to that is no. So we would write no over here. A square has opposite sides congruent, but square is not the rectangle. The inverse comes from the conditional. So the inverse, I'm going to insert the word not into the original conditional statement. So to prove this true or false, you just have to think of all the shapes that are not rectangles. So you're saying if you don't have a rectangle, then you don't have opposite sides congruent. Well, we know that this has to be false, because if you think about our square example, with a square, we know that it's not a rectangle, but it has all opposite sides congruent. Okay, we could also think of a rhombus. We could think of lots of shapes that would apply that would make this false for our inverse statement. Go ahead and read through these examples and see if you can figure out the truth value for each. Remember, in order for a sentence to be true, every time the hypothesis is true, the conclusion must be true as well. If your sentence is false, you have to provide the counterexample. So give a reason or an example on when the sentence is false. Good luck.